Hello students, welcome back. Now let's discuss normal distribution, which is an example of a continuous random variable. The reason we study normal is because number one, it's simple, and number two, it's useful. What is normal distribution? Oh boy, it's intimidating, but it's a distribution of this form. Here's a probability density function, and its integral version is the cumulative distribution function. It's called Gaussian distribution, named after German mathematician Gauss. And here is a visualization. For various sigma values, let's see, this is randomized and we have green and red and blue are so close to each other it's hard to see. Let's run it again. Okay, that's better. Green is the standard case, sigma is 1. And blue is sigma greater than 1. As you can see, more spread out. You see, sigma standard deviation is more spread out, right? And this is, red is 0.76 something, so smaller sigma, smaller standard deviation. As you can see, more concentration toward the middle. Green is the standard case 1. See here this picture. Blue, bigger sigma, more spread out. Red, smaller sigma, more concentration toward center, less spread. And as for CDF, okay. Now, there's something called standard normal distribution, and that is really, really important in terms of practical computation. And theory is a little bit difficult, and I do not want to emphasize the algebraic aspect. Instead, where's the visualization? It's not here, so it looks like I have to stop the playback and get a separate file. Stay with me just a moment. Okay, here we go. Standard normal distribution is a special normal distribution given by this density function and this cumulative distribution function. From arbitrary normal distribution, we can apply the standardization z equals to x minus mu over sigma, and you end up with this, and that's something we're going to discuss a bit later. For now, let's not focus too much upon these symbolics, but instead let's focus upon how to utilize it using the normal table. So here's a normal picture going up and down, the same picture you saw before, and this is standardized, so the average, the mean is 0. So 0 is down right in below here, and when z is negative, like these negative values, we have probabilities to the left, and these are visualizations of CDF, cumulative distribution. So everything to the left. And z values are associated to all the columns here up to first decimal digit. Negative 3.4, negative 3.3, all the way up to 0 is there. And all these corresponds to second decimal digit. If you go to the second page here, now z is positive. 0 is right in the middle, z is now to the right, is positive. So we have this probability here shaded. So that's the CDF, cumulative distribution. And z value is 0 point something all of here up to first decimal digit. And the second decimal digits are here. And let's discuss how to use this normal table. Here's an example. Probability that z is less than or equal to 1.285 is about 90%. Let's check that. Let's go to that normal table. 1.285. So let's go to here up to first decimal digit. You can find it from the first column. So 1.2 is here. 1.2. Now the second decimal digit is coming from those here. So 1.28. 1.2 is here. 1.28. I'm getting 0.8897. That's for 1.28. And then for 1.29, I get 0.9015. Let's see. How can I get pictures here? So 1.2 is here. And then 1.28. And then 1.29. So we have 1.28, 1.29, that's 1.28, that's 1.29, and then these numbers, 0.8997 and 0.9015, corresponds to the CDF for 1.28 and 1.29 respectively. So 1.285 must be somewhere in the middle, and that should be about 90%. Does it make sense? That's how I do it. Let's come back to the next example here. How about this? Less than 1.645. That's got to be about 95%. Let's see. How about that picture again? 1.6. So let's go to Z. 1.6 is over here. And 1.6 fourth column, fifth column. So we're getting something like this. So 1.6 and 1.64 is here. 1.65 is here. Let's see, 1.64, 1.65, 0.9495, 0.9505. So 1.645 is somewhere in the middle, so it's associated to about 95%. That's how you read the table. Make sense? Now let's go back. Now let's go back to this Mathematica notebook. So 1.245, no, 0.285 here to the left is 90%. By default, to the right is about 10%. Here 1.645, to the left 95%, to the right therefore 5%. How about the next one? 1.96, to the left 97.5%, to the right about 2.5%. Let's check that. Let's go back to that table here. And 1.96, so right, 1.96. So 1.9 is here, up to first decimal digit, and 1.96 is there. So we are looking at this part. So 9750, 97.5%. Is that what we found previously? Yes, indeed. So for standard normal distribution, we can find out the CDF using the table. More computation. All right, here's a nice example. Probability that z is less than or equal to negative 1.64. Probability is z is greater than 0.62. And then in between, okay, nice problem. And let's do all those using the normal table. So negative 1.64 shaded to the left. Let's go to the normal table. Negative 1.64 is so negative, so you have to go to this part. Negative 1.64 it's here, and 1.64 is there, so negative 1.6. And that is negative 1.64. This is the second decimal digit. So 0.0505, that's shading to the left. So that's the answer we are looking for. 0.0505, negative 1.64. Make sense? Let's check. Yeah, it's shaded to the left, about 0.0505. Now let's do this. Z is greater than 0.62. Now this is going to be a bit trickier. Let's go back to the table. 0.62. So all these are negatives, so 0.6 should be in the second page. 0.62. 0.6 is here, 0.62. Okay. So 0.6 is here. 0.62, so we are looking at this one, right? 0.7324. 0.7324. So 0.7324. Is that right? No, not really, actually. 0.7233 is actually CDF, shaded to the left. But what we want is z greater than that, so the other side is what we want. So I need 1 minus of that. That's going to give me the right-hand side, 0.2676 something. So this is wrong. If you just get blindly from the table, it's always the left-hand side shading. But we want greater, so what we want is 1 minus of that. And if you do it, you're going to get, what is it, 0.2676. That's what you're going to get. Here, Mathematica uses a little bit more decimal digits for a little bit more accurate computation. But if you're using the table, you have only 4 decimal digits. So you'll have to be satisfied with just 4 decimal digits. So 0.2676, and that's going to be the answer. So when do we have 1 minus? If you draw the picture, you'll see. If you shade to the right, that means you have to do 1 minus thingy. Now how about in the middle? Between 1.64 and 0.62, if you draw the picture, you'll see middle. Net is 0. Okay, alright, that's better. Negative 1.64 is to the left, 0.62 is to the right. I would like to have a little bit bigger screen. So, alright, this way I'm going to satisfy the lower space for caption. So if you're reading caption, please be careful here. So this is what we want between negative 1.64 and 0.62. And how do we get that? less than 0.62, green, minus less than 81.64, blue. So if you do green minus blue, then you're going to get red. See that? It's a geometry problem. So what you want is green minus blue. So green less than 0.62, which we calculated in part B, and blue less than 81.64, which you calculated in part A. So if you do that, subtract one from the other, then you get what you want. Here I use Mathematica, so I have 6 decimal digits, but if you use normal table, then you're going to get 4 decimal digits, a little bit less important, a little bit less accurate, but that's okay. Okay, let's go back and let's get this basic math assistant back so that I can write more easily or effectively. So how do we work with normal table to answer questions about the standard normal? I think we went through sufficient exercises. Now, we have to do some inverse computation, but we have enough time. Now I guess I'll come back and discuss that in a separate video. Let's have a brief recap. We discussed normal distribution. Don't pay too much attention to symbolic expression. Graph says it all. Going up and down like this, and it depends upon the standard deviation. Big standard deviation, more spread out as this blue. Smaller standard deviation, more concentration toward the center. And the center I said, but it's actually the mean. And mean is mu, so centered at mu. But if you take standardization and z is x minus mu over sigma, if you do that, then you end up with standard normal. Again, don't pay attention to this as symbolic expression. The key is a normal distribution with mean 0 and standard deviation 1. Mean 0 and standard deviation 1. And we can use the z table for that. And examples include, well, some examples like these. Not very good examples. Here are much better examples. You can draw the picture and to the left, and then how do you find this one out? You can look up the table, and we discuss how to look up the table. Of the first decimal digit, left-hand side column, and then the other columns are all about second decimal digit. Now, what if you have to get z greater? Then you just don't get you don't get this number directly out of the table, because if you do that, you're going to get this CDF, left-hand side shading. What you want is right-hand side shading, so you have to do 1 minus of that. And then what if you do between these two? Draw the picture and you'll see green minus blue. So all you need is a subtraction. Look up green, and for 0.62, look up the table. We discussed how to do this in part B. And blue, and we discussed how to do that in part A. Subtract one from the other, then you get the middle part. You can do various things geometrically if you draw the picture, and I really strongly suggest you draw the picture with your hand. It doesn't have to be pretty, but it has to be attempted. Okay, so much for the first half of normal distribution. We're going to come back and discuss the rest in a separate video.